First of all, I give thanks for life, yeah. I thank the Father for
Welcome again, guys, to one of Vextronics' videos. I am Daryl Barrow, Chief Audio Engineer and Acoustician here at Vextronics, and today we are going to talk about the decibel. Now, everybody knows the decibel to measure volume. What you don't know about the decibel is that the actual unit that is used to measure the intensity of sound is called the bell. And the decibel is 1/10 of a bell. And why do we use the decibel instead of the bell? It's because the decibel is a logarithmic scale. The bell, when it measures volume or the energy of sound, it's actually really large numbers. So we use a logarithmic scale, the decibel, which allows us to express these really large numbers as small numbers. All right, and what we're going to focus on is how the decibel is related to soundproofing. So when it comes to soundproofing and measuring the intensity of the sound that we are trying to stop, we came up with the weighting system. What the weighting system does is gives us two different ways to measure the intensity of sound. Just like we have centimeters and we have inches to measure the same distance, it comes the same thing with sound. So what happens is, because of the sensitivity of the human ear to certain frequencies, namely 500 hertz to 8 kilohertz, they came up with one measurement that's more sensitive to these frequencies and another measurement that is not sensitive to these frequencies. And those are dBA, or the A weighting, and dBc, or the C weighting. What dBA is, dBA measures sound similar to how a human would hear or interpret sound. And that is that it will measure the frequencies that the human ear is most sensitive to, which is 500 hertz to 8 kilohertz or 8,000 hertz. It takes into account those frequencies most, and it tapers off anything above 8 and anything below 1 kilohertz. All right, and if you watch this graph representing how a weighting works, you can see between 1000 or 1 kilohertz all the way up to 8000. It's relatively flat in how it measures, but it tapers off above and tapers off below. Right? So it's really not taking into account low end or bass or extreme high end. But if we look at C, the dBc, the dBc does not take into account the sensitivity of the human ear. What it does, it measures all frequencies equally. So it's great to use dBc when we're dealing with loud noises or when we are dealing with sounds that have a lot of low end in it, namely sound systems, generators, and stuff like that. Okay, so if we look at the chart of dBc, we could see that it is relatively flat throughout the frequency range. There is some taper off at extreme low end, namely 31 or 30 hertz go down, and there is some taper off on the high end. And why it still tapers off is that most humans cannot hear above 16, 17 kilohertz. We just can't hear it. Because of age, because of noise pollution. That's a whole other topic. All right. So when it comes to soundproofing, we want to ensure that we use the correct weighting when we are measuring the sound. Many times I get decibel readings from clients and they use the wrong weighting, because if you use dBA to measure something that has a lot of low end frequencies, it's not going to give an accurate response of the volume. You need to use dBc, which gives the low end frequency response. Okay, so I hope this helps to clear up anything when it comes to the decibel. Once again, I am Daryl Barrow for Bextronics, and I'll see you again in our next video.
First of all, I give thanks for life, yeah. I thank the Father for blessing me with enough health and strength and bacchanal vibes to make my soul feel so free.